Very good morning to all. So I am Dr.C.Senthilkumar, Associate Professor, Department of Mechanical Engineering. The continuation of lecture of series in the course of heat and mass transfer on the topic of convection. So this video having the concept of electronic equipment cooling. So we all know what is electronic equipment cooling. This is an emerging technology. Every mobile phone needs cooling to avoid the hanging of electron flow inside the chip, and all the laptops and all the electronic gadgets, including servers and all the even the fan has maintain cool to maintain the concept of electronic equipment electron flow properly. Let we get into the course now. So we teach design thinking concept in our SNS institution, and this is the beginning of the topic where we explain the design thinking for electronic equipment cooling. In the define part and empathize part, the thermal issues, hotspot failures were analyzed, and in the define part, thermal analysis and space power consumers were find out. In the ideate part, heat sink design and fan liquid cooling innovation concept were innovated. After that, we go to the prototype. In the prototype, we make a prototype and we test it using simulation and mock-up testing. So this is the design thinking based analysis of electronic cooling. Coming to the next concept, electronic cooling is critical need. It's reliability. It's high temperature cause failure that we know, as I said. High temperature of a laptop, electronic gadgets, mobile phones, and iPod, and all the electronic servers gets failure because of electron faster flow. So its performance, throttling slows down the process. So high load, it's like high load. So prevents the fire and hazards. So this electronic cooling prevents the fire and hazardness. So as I said, the coming topic is factor influencing heat conduction. So thermal conductivity. So the ability of material to conduct heat. If it is happening faster, the cooling rate also will be faster. Silicon chip. The source of heat in electronic device is the silicon chip. It has to be the additional heat or trapped heat has to be exhaled by the mechanism. If not, the system gets hanged that we met in the previous decade. It is eradicated using the electronic equipment cooling devices that we are going to see. The heat sink, the device that dissipate heat. Heat sink is a word terminology. It is used to say how the heat is trapped or taken out from the mechanism. Package, a protective casing around the chip. That we'll see one by one. So convection heat transfer, we know already in the previous lecture I taught about the what is convection. So what is convection? And convection involves moving of heat from a solid surface into the fluid. What are the types of convection? Natural convection and forced convection. And natural convection happens naturally. Forced convection happens due to force induced on the hot area. So what is thermal resistance? It's a resistance offered by the system. How does heat flow? It flows moving the high temperature to the low temperature based on the first law of thermodynamics. What is the goal of thermal resistance? Is to reduce the resistance of the heat flow path using high quality materials and efficient air. So coming to the heat sink design, the surface area has to be high and material such a way that has to be designed like that. Efficient heat distribution must happen over the heat sink design. So thermal interface materials, let me see. The problem is microscopic gap exists between the chip and a heat sink. This heat sink shown in the diagram has to be, it is focused here. This gap has to be released using the mechanism or fluid or the material, whichever we have chosen. And the solution is layer filled with some gap. Even millimeter amount of gap has the path to flow the fluid from one point to another point. So the next problem is microscopic gap exists between the chip and the heat sink. So that has to be taken care by the TIM layer, that is thermal interface material layer, for a solid thermal bits to the ambience. Coming to the next one, liquid cooling system. When air cooling reaches its limit, liquid cooling is employed. So this liquid may be a refrigerant or phase change material or the some other material which has the capacity to transfer the heat in faster rate. So there is a fan. Already in old decade computers we had a fan. So along with the fan we have the fluid here to transfer the heat in faster rate. Water blocks, liquid circulates directly over the heat source. Radiator, the liquid carries heat to large radiator where the fan dissipates it into the environment. This method is much more efficient than air due to the higher heat capacity of the fluid. Coming to the phase change heat pipe. So the heat pipe is a machine or mechanism of heat sink having the shape like a pipe so that inside the pipe they fill the phase change material. We know the wax when we heat it becomes as a vapor. When we freeze it, it becomes as a solid. Like that, there are several phase change materials are there. So that is filled inside the phase change the pipe mechanism that is placed on the electronic chip where the heat is high, it is developed high, that is absorbed by the fluid, it is becoming vapor and going outside on the fan, through the fan, it is exhaled, the heat is exhaled, it is becoming liquid and coming to the return phase. So this is a cycle followed by the heat pipe. It's a mechanism to transfer the heat from the electronic gadget to the atmosphere. So with this, I conclude the session. Thank you very much for listening the session. Any queries or any concept over this one, you may contact me. Thank you very much.